Okay, so this is the last question of the Evolution of the Living Earth exam for giving you some feedback. So this is on the biogeochemical cycles part of the course. So if you did answer this question, and if you answered well, I guess you'll hopefully understand why I have this picture of a lobster to begin the video with. Right, so if we move on and just have a look at the mark distribution. So not many people answered this question. So this is D8, the last question. So this is the dark blue in this histogram, which was a shame. It had a slightly higher average than some of the other questions for my parts of the course. So good job if you did well on this question. Lots of people did well, which is good. Some people not so well. So we'll just have a look through this question and have a look at what we were expecting. And yeah, so yes, next slide. So this is the question. So it was a question about sulfur and its effect on climate. So the first part of the question really asking about what are the forms of sulfur. Fairly straightforward starter. Quite a lot of marks for this. I thought it was quite generous, but then very easy to lose marks if you didn't know the forms of sulfur. So there we go. Easy come, easy go. So the next part of the question really, how does sulfur affect climate, and how can it be involved in positive or negative feedbacks? Which the feedbacks part of it was people missed out on megabucks there. And then again, the last part again, a list what are other sources. So very much a what are the things kind of question, which you either knew or you didn't. And asking for evidence that these things in the past, these sources of sulfur have affected Earth's climate. So let's move onwards and ever upwards. Right, so the forms of sulfur that are present in the atmosphere, and the ocean. So really this is one of the slides from the sulfur lecture, and this is really kind of what I was looking for, just a list of the things where sulfur is and what kind of sulfur there is there. So if we start out with the atmosphere, so the kind of forms of sulfur in the atmosphere are sulfur dioxide, sulfate aerosols, and these are the main forms of sulfur in the atmosphere. There are also these organic forms, so you could have received a little bit of extra credit if you'd kind of just listed all of these things, but then said that these are the most abundant forms of sulfur in the atmosphere, but extra marks for the super top end of the grade range. In the hydrosphere, most of the sulfur is a sulfate ion, so because it's very soluble in the ocean. Now there is also some of these minor dimethyl sulfides and carbonyl sulfide as well in the ocean, because it's a gas in the atmosphere. So some of these minor atmospheric gases will also be in the ocean as well. So you could have put those down and I would have given credit for that as well. But the real important one is that the main form of sulfur is this sulfate ion. And then in the lithosphere, the forms of sulfur really are rocks. So I even gave people marks for writing rocks. But what we're looking for is the minerals that contain sulfur. So there's the reduced kind of form of sulfur, iron sulfide, pyrite, and the oxidized form, which quite often forms this mineral gypsum, an evaporite mineral. Those of you going to Spain, lucky people, on the geography or the geology and physical geography field trips, you'll be seeing lots of gypsum in some of the evaporite deposits there. It's quite exciting. Also, there's some sulfur in fossil fuels as well. Any organic matter that's forming into rocks or is incorporated into rocks will also incorporate some sulfur into it. So those are the sources, and there were a bunch of marks available for you to list those things and get some points. So there you go. That's what you could have had. So the next part of the question, part B, explain the potential mechanisms by which emissions of sulfur from the ocean could be a positive or negative feedback on atmospheric warming. Okay, so first of all, you can kind of break this question down into its kind of constituent parts and think about actually what are the emissions of sulfur from the ocean. So how does sulfur get from the ocean into the atmosphere? How do these sulfur species, when they're in the atmosphere, affect climate? And then how are those emissions dependent on climate? So therefore, how do they become a feedback? So a feedback is a kind of a change in the climate system that is the result of a change in the climate system, but also causes a change in the climate system. So can either reinforce the initial change or can kind of counteract it. So that's what the question is really asking you to explain all of those different kind of steps going through from how does the sulfur get into the atmosphere, how does it affect climate, is it a feedback, positive or negative? So again, positive or negative being, does it reinforce the initial change, not does it cause a warming? You can have positive feedbacks that cause coolings. If the initial changes are cooling and it gets reinforced and get more cooling, that's a positive feedback. Anyway, so the main emission of sulfur from the ocean is through this dimethyl sulfide, which is produced from the decay of organic matter. So that gets produced in the ocean, and then that comes into the atmosphere through gas exchange, which is related to Henry's law. So details of that would have been good to get kind of extra super bonus, but what we're really looking for is the production of dimethyl sulfide through the decay of organic matter in the surface ocean. Okay, so that's the main thing. And then when that dimethyl sulfide gets into the atmosphere, it doesn't last very long. It gets rapidly oxidized. Now, that would be good. You get more marks from saying it gets rapidly oxidized, and then incorporating there we are, move the mouse around randomly, some equations. But again, the super extra bonus credit. Now, the important thing is that oxidation of the sulfur species is oxidation to sulfuric acid, ultimately. So we oxidize the dimethyl sulfide to sulfur dioxide, and that sulfur dioxide reacts with water to form sulfuric acid. Now we get on to the climate effects of that sulfur species. Could say the sulfur aerosol acts as a cloud condensation nuclei. That would be good. You could have gone into a little bit more detail about why it acts as a cloud condensation nuclei, because it condenses. It's got a really high boiling point, so it stays as a liquid and is really hygroscopic. So water loves to condense onto these little droplets of sulfuric acid. You could then go on and say, what's the effect of these cloud condensation nuclei on clouds? So you could say they increase the albedo. Or you could go into a little bit more detail and say they make the droplet size smaller, which means the clouds appear brighter. They also take longer to rain out, so they last longer in the atmosphere. This increases the overall atmosphere or albedo of the atmosphere, so we lower the planetary temperature. Now, you're saying we lower the planetary temperature. You could include the temperature equation, the Ts equals brackets with a quarter, and then the S naught brackets 1 minus alpha over kind of the stuff at the bottom with the sigmas and the epsilons and the 2 and the minus and all that kind of stuff. This equation, which I was quickly remembering, you could have had that equation there. So you could have explained the process by which it affects climate and included that climate relevant equation for the extra bonus marks. Everyone likes the extra bonus marks. Right, so getting on to the last part of the question, how do these things act as feedbacks? So this is where the claw comes in, and the lobster. There's no lobsters really in this thing at all. It's just a thing with a claw. So the idea is that if you have an ocean warming, you get more plankton growth because reactions kind of go faster with hotness. That means you get more dimethyl sulfide production, more sulfur emitted into the atmosphere, and you have more cloud condensation nuclei. You have a higher albedo, more solar radiation reflected back into space, cooling of the planets. That counteracts the initial warming, so this is a negative feedback. So you could explain that as a negative feedback, but there's the alternative kind of hypothesis, which is that a warming of the ocean actually causes a decrease in plankton growth. And it's this first step, which is the critical distinction between, does this sulfur emissions from the ocean act as a positive or a negative feedback, is what is the initial reaction to the surface ocean kind of ecosystem to ocean warming. Do you get more phytoplankton growth, or do you get less? And you could get less because although it's warmer, that might cause the ocean to be more stratified. You have a more heating of water in the surface layer that makes it more buoyant. It's harder to mix water from the deep ocean to the surface, so you get fewer nutrients or less nutrients. Anyway, there's less stuff there available for plankton to use as nutrients, so that would reduce the primary productivity and therefore lead to a positive feedback. Okay, because you have less sulfur emissions, you have therefore less cloud formation, and you have a lower albedo and an increase of temperature, which acts as a positive feedback. So, so explaining those two mechanisms was what was really looking for in these two competing hypotheses, and critically, the importance of the initial kind of effect of increasing ocean temperatures. Does that increase primary productivity in the ocean, or does it decrease it, and why might that be? So those were the things we were looking for that part B. So part C, which was the last part of the last question. Oh, I guess it wasn't really the last question because you could have done them in any order you wanted to. But anyway, part C, we digress. So other than the ocean, so most of the questions so far has been talking about the ocean sulfur cycle. But again, we're just asking for a list of what are the other sources of sulfur to the atmosphere. Okay, so that's kind of one part. And what evidence that these sources have affected Earth's climate. Now, this last part was perhaps misinterpreted by quite a lot of people. Many of you just wrote the mechanisms by which sulfur can change climate, which was really part of the answer to B before. So if you wrote it here and didn't write it in B, then you got some credit for that. But if you just wrote it again, then not so much. So what we're really looking for in this second part is, what is the actual evidence that climate changed in the past due to there being increased sulfur in the atmosphere or decreased sulfur in the atmosphere? Going on and looking at some of the first part of the question, again, it's really just a list of things we're looking for here. What are the other potential sources? So these are some slides from the lectures. So there's dust being bits of rock which contain sulfur being thrown up into the atmosphere, add sulfur to the atmosphere. Burning biomass, so plants, burning animals even, those things contain some sulfur. If you burn them, that goes up in the atmosphere. Also, the dimethyl sulfide process of decaying organic matter, that happens on the land as well as the ocean. So you could have said that again, a bit of a freebie, but not many people are kind of picked up on that one. But it is a land source of sulfur to the atmosphere. But some of the big ones, which I think most people kind of like cottoned onto in some way or another, were emissions from volcanoes. So when a volcano erupts, quite a lot of sulfur gets emitted into the atmosphere. And also anthropogenic sources. So when we burn fossil fuels, those are effectively just burning organic matter, and that organic matter contains some sulfur, which gets put into the atmosphere, which is kind of bad. So this last part, what we're looking for here is really some evidence that sulfur is important in the climate. So some of the evidence is that where we have a record of kind of sulfur change, do we have a coexisting record of climate change that shows the response that we're kind of expecting? So one of the lines of evidence is climate records from ice cores combined with records of acidity or rainfall acidity, or it's not rainfall, snowfall acidity from ice cores. So that's what we saw in this slide here, which was from one of the lectures. We can see that the acidity in the core here. So when the acidity is higher, we tend to have that would corresponds to more sulfur in the atmosphere in the form of these sulfuric acid aerosols. That corresponds to periods of cooler climate. Okay. Acidityness, coolness, less acidityness, warmness. So that's a line of evidence that we have changes in sulfur content that coexist with changes in temperature. We can also look at evidence of the magnitude of climate changes. So this is another example from, I think, the same lecture, where we can see that the temperature anomaly for the year after a large volcanic eruption, so the magnitude, so how much colder it gets, kind of corresponds quite well with how much sulfur was emitted by any particular eruption. So we can see that we have kind of large eruptions that emit lots of sulfur. So we've got the amount of sulfur increasing to the right here. They have a temperature drop of 1 degree, whereas smaller eruptions that emit less sulfur have temperature changes of, in this case for Mount St. Helens, 0.1 degree. Okay, so it's important here that this not only shows a relationship between kind of there being a cooling event and there being some sulfur emitted into the atmosphere, but the relationship holds at kind of different scales. So if you put more sulfur into the atmosphere, you get a bigger cooling effect, which is an additional line of evidence other than just the two things happening at the same time. So those are the things we're looking for, that kind of evidence. Now, for the modern climate change over the last 100 years or so, and we've put lots of sulfur into the atmosphere, the evidence is a little bit more tricky to deconvolve because the cooling effect of fossil fuel burning sulfur, which adds to aerosols in the atmosphere, has been superimposed on the much larger effect of the CO2 going into the atmosphere and warming. But you could conceivably include some evidence based on some of the climate models which have included and not included the sulfur aerosol effects. Anyway, so that's the end of this video. Hopefully you've got some idea about what the questions were asking and how that maybe contrasts with what you thought they were asking, and what we were looking for in some of the answers. And when we say we, I mean, of course, me, because I'm just a person with, some exams and, fun times. Anyway, so if this is the first one that you've watched of the videos for this exam feedback, have a look at some of the other videos of questions you asked and answered. I asked the question. And also the maybe look at some of the ones you didn't ask and whether you could have maybe answered those. Answered yes, yeah, maybe. Anyway, there you go. Off you go. Do that. Any questions to me later? And stopping recording.